Okay. Okay. I will get back to you. I'll check it and I'll get back to you in the next class.
Okay, sir.
Okay. Any other doubts or confusions? Okay. So we'll start today's class. First, we'll look into what we were discussing in the last class, and then I'll move to today's class. So first, we will look into last class what we had discussed. So basically, the last topic which we were discussing was Gaussian elimination, right? So in Gaussian elimination, what we do, I'll go through it once again, and then I'll show you the MATLAB code for that, how to go about it. So basically, Gaussian elimination is a technique which is basically present to solve a system of linear equations, right? Suppose you have n equations, there must be n unknowns, right? So if there are n equations and n unknowns, then your system of equations has a solution, and we can find it out through different methods. So today we will be learning about uh, today we'll be learning about two methods like the Gaussian elimination and the LU decomposition method, and then we also have many iterative techniques for solving the system of linear equations like the Jacobi's method, then the Gauss-Seidel method, which we will be looking into today. So basically in Gaussian elimination, you have here I have taken three equations and three unknowns. So first of all, you need to form the two matrices, which is the first one is the coefficient matrix, which is A matrix here. And the second one is the RHS matrix or the source matrix, we call it source vector or source matrix, anything you can call. So then using these two matrices, we form the augmented matrix, which is written as A slash B. How we form that? We just write A matrix as it is, and then in the last column we append the B matrix or the source matrix. So it is basically a 3 cross 4 matrix here. So whatever operations you perform, it's not on the source matrix, but it is on the augmented matrix or the A slash B matrix. Just remember this. Many of the students do mistake in they perform the operations in the A matrix, which is not correct. So then what was our objective? Basically, this A slash B matrix, we have to reduce to upper triangular matrix. What is an upper triangular matrix? An upper triangular matrix is all the elements in the principal diagonal and elements above the principal diagonal of a matrix if they are non-zero, and all other remaining elements are zero. That is, all elements below the upper diagonal are zero. Then we call it as an upper diagonal matrix. Similarly, we have the lower diagonal matrix, which we will be using shortly in the LU decomposition method. So it is just the reverse of upper triangular matrix. Lower diagonal matrix is the elements in the principal diagonal and the elements below the principal diagonal are non-zero, and all elements above the principal diagonal are zero. So that is the L matrix, L and U matrix we have. So now our job is this A slash B matrix, we have to convert it into a lower triangular matrix. So now we know that in a matrix, we can perform these row operations and column operations, right? So that doesn't change the matrix, basically. It is an equivalent matrix, we say. So the first step here is we have to convert this A slash B matrix to an upper diagonal matrix. So how can we do an upper diagonal matrix? So what we have to basically do, first we have to identify which is the principal diagonal element, right? So my principal diagonal element here is 1, 3, 7. Right. So all elements below this principal diagonal should be 0. So what are the elements below my principal diagonal? It is 2, 3 and 5. So these three elements should be 0. For that I have to perform appropriate row and column operations. Okay. So first step is we will make this 2 as this second row first element, first column element, that is 2, as 0. So how can we make it? Basically, the row corresponding to 2 is R2, that is the second row. So R2 we replace by R2 minus M into R1. What is M? M is my multiplier. So M is basically A21, that is the 2 1 element divided by the 1 1 element. So that gives me 2. So R2 we replace as R2 minus 2R1. That is, every element of row 2 should be replaced by the current element in row 2 minus 2 times the corresponding element in row 1. So the first element becomes 2 minus 2 into 1, which is 0. Next element becomes 3 minus 2 into 2, that is 4. 3 minus 4 is minus 1. 4 minus 2 into 1 is 2. 20 minus 2 into 8 is 4. So first objective is achieved. We have made this element as 0. Now two more elements are remaining, that is 3 and 5, both of which are in the third row. So now it is confirmed that we have to perform the operations in the third row. That is R3 equals to something we have to replace. So for 3 to make it to 0, R3 should be equal to R3 minus M into R1, where M is A31 by A11. Right? So A31 by A11 is 3 by 1 is 3. So R3 should be replaced by R3 minus 3R1. So we have the third row will change. Again in the third step, so two elements are already 0, right? This element is 0, this element is 0. Only minus 1 remains, which we have to make it 0. So if we want to make it 0, now you have to see. Here this element, the 3, 1 element is already 0. So if you perform any operations with R3 with R1, then this element will change because this is 0 and this is 1. If you perform some operations, then this will change, right? So that is not correct. We don't want to disturb this 0 element. So what we have to do, we have in the second row, we have 0 here. So 0 and 0, whatever operation you do, it will remain the same. So we operate on R3 and R2. So R3 and R2, if you see, here is minus 1, minus 1. So just if we subtract R3 and R2, we will get this element as 3, 2 element as 0. So that is what we do here in step 3, R3 minus R2. So 0 minus 0 is 0. Minus 1 minus minus 1 is 0. 4 minus 2 is 2. 10 minus 4 is 6. So now you can see at the end of step 3, A slash B matrix is an upper triangular matrix. So now the question arises, why we need to convert to an upper diagonal matrix? How is it going to help me in my solution? So now we will see that. So the next step in Gaussian elimination is, after you convert it into your upper triangular element, we basically do the back substitution. So what is meant by back substitution? This upper triangular matrix conversion is clear. Any confusions? Anyone?
No, sir.
It's clear, right? Anyone? Any confusions? Okay, fine. No, now after the this upper triangular matrix conversion, we have this matrix, right? 1 2 1 8 0 minus 1 2 4 0 0 2 6. So we substitute it in the backward direction. That is, the first row, the first column here corresponds to your first unknown variable, which is x here. The second column corresponds to your second unknown variable, which is y. Third column corresponds to your third unknown variable, which is z. And the last column, 8, 4 and 6, that basically represents your RHS matrix. So now if you want to from equation we converted to matrix. Now we want to convert from matrix back to equation. So how can we do that? See, in the last row, the element corresponding to x is 0, right? In the second row, second column, the element corresponding to y is again 0. Only the element corresponding to z is 2 and the RHS is 6. So we start from the bottom because in any upper triangular matrix, the last row will always have all elements, all entries as 0. Only the last element will be non-zero. So that when if we want to convert this R3 to equation, what will be the equation? 0 into x plus 0 into y plus 2 into z equals to 6. So already your x and y variables are eliminated. Only you have coefficient corresponding to z. So you have an equation with only one unknown, which you can easily find out. So 2z equals to 6 and z equals to 3. So we start in the backward direction, that is from bottom to top we will move. That's why it is called back substitution. So now we got z equal to 3. In the second row, if you see, the element corresponding to x is 0 again, and y and z are coefficients are there. So it is minus y plus 2z equals to 4. Z we get from the previous value. We substitute it and we get y equals to 2. The last row, that is the first row here, all the elements are present. That is x plus 2y plus z equals to 8. We have y and z here and we substitute x and we get the solution as the unknown vector is 1, 2, 3. Is this method clear to you?
Yes, sir.
Any confusions in the logic here if you face, then you will not be able to understand the MATLAB code, because the MATLAB code is totally logical. Every step you have to understand, then only you can do the coding. Okay, so I'll move to the MATLAB code for this. So if you see here, just a second, one generalization I will do here for the back substitution. So what was my matrix? It was basically 1, 2, 1 second. 1 2 1 8 0 1 7 2 4 here we'll do 1 2 1 8 0 -1 2 4. So this was my augmented matrix, right? So from this we did the back substitution. So now like we did here 2z equals to 6, but how to do it in the MATLAB, because we need to have a generalized formula for this. So what we do is we take a general matrix. Okay, say a slash b is a11 a12 a13, then this is b1 a21 a22 a23 b2 a31 a33 b3. Fine. So now what we do is, see, if we write like this, a31 into x plus a32 into y plus a33 into z will be equal to b3. From this, these two terms will go off because a31 and a32 are always 0. So z is basically b3 upon a33. So this is your generalized formula for the z. Then you have a21 into x, a22 into y, a23 into z equals to b2. From this we strike off the a21 element because this is again 0. These three elements are 0, right? So you have basically a22y plus a23z equals to b2. From this we want to find out b a2 y, right? So it is basically b2 minus a23 into z by a22, because so this is y. So z you can find out from here. So z is basically b3 by a33. Again z you can substitute. Again we have a11x, a12y, a13z equals to b1. So you want to find x from here. b1, 12y, 3z by a11. So like this you have a, you can generalize this. Again z you can substitute and then you can form a generalized expression for this back substitution technique. Is this clear?
Yes, sir.
Okay. So now I will move to the MATLAB code. I'll show you this. Just a second. Is the screen visible to you?
Yes, sir.
So you can see here, I have written the code for this Gaussian elimination technique. So I'll explain you line by line. I'll explain you how I have written the code. See, first of all, line 5 and line 7, I have entered the A, which is the coefficient matrix, and B, which is the RHS matrix, right? Then I have found out how many unknowns are there. That is whether it is 3 unknowns, 4 unknowns, 5 unknowns. It can be anything, right? Just a second. So n is the number of unknowns. Then I have formed the augmented matrix like this, because A is a say 3 cross 3 matrix, and then you have your B, which is a 3 cross 1. So A, B, if you write like this, it will form the 3 cross 4 matrix which I showed to you. Then I have to hit this part from line 13 to line 23. This part I'll highlight this part. This is your conversion to upper triangular matrix. Write in comments here. Conversion to upper triangular matrix. So you can see here, first I'm running the loop kk, which is the outer loop from 1 to n minus 1. And the inner loop I'm running ii, which is from k plus 1 to n. Then I'm calculating the multiplier. That is for every row, that is when I'm eliminating the 2 1 element, then it is a21 by a11, right? So ii is the value of that particular row, and kk is the column. So it is always a21 by a11, or when you do for third row, it is a31 by a11, or the second row of the second column of the third element, third row, if you do, it is 22 by sorry, it is 32 by 22. Like that it is going on. And this line 23, that basically so augment of ii. Okay, one thing I'll first show you, then it will be easier to understand for you. So how to first of all enter matrix, right? So first, suppose you have the matrix as 1 2 3 row wise. I am telling 1 2 3. Just I'll write it. Whenever you have a call, means second row, if you want to go, then you have to put a semicolon. 3 4 1 2 3, suppose 4 5 6, then you have 7 8 9. So this is this matrix, A matrix. So here you can see the how I have represented the elements. If you want to mention it is in a separate column, you have to use the semicolon. Then suppose the row matrix, if you want to enter, it is 1 colon I'll use. So then it is 1 second. So it is a 1 2 1. If I want to mention along the row, just I'll write 1 2 1. Then it will be a row matrix. Is the way of representation of the matrix in MATLAB clear?
Yes, sir.
Okay. So like this you have to enter, and here if you come back to the code, so suppose you have your A matrix is this one, right? So if you want only the first row, how can you represent that? A of colon. If you write like this, it will give you only the first row, that is 1 2 3. If you want only the say the first column, so you will write A of colon comma 1. So that gives me the first column, which is 147. If you want only the second column, you will write A colon comma 2, which is 258. So like this here, this line 23, augment of ii comma colon, that means at a time I am replacing the entire row. That is, ii is the particular row which we are in, say the second row. So the second row will be replaced by this augment of ii comma colon, which means the values currently in the second row minus the multiplier into the pivot column, the pivot row which we are particularly taking, which is augment of kk comma colon. So in this way, if you dry run this one, just take n equals to 3, and then you evaluate step by step each step what we are doing here. So then you can understand it better. So now after this we do the back substitution. Now in augment we have an upper triangular matrix, right? So now what we do the back substitution. So what we are doing here, see line number 28, we are just initializing the sum, which is to in back substitution, as I explained you, it is the generalized formula I explained, right? Which is which is like the last element, that is z, is equal to b3 by a33. Then you have the second unknown, which is y. So there you have a summation, that is B, the source element minus a particular summation. That summation I am including here as sum equals to 0. I'm initializing. And in the backward direction, we are going, see, I equal to n to minus 1. That is the second thing basically represents the decrement. That is, we are starting from 3, third row. We are reducing by 1 and we are going till the first row. Again, you have this inner loop for the column and we find the sum here. If you find the sum like this, then you find out x of I, which is the augment of I comma n minus 1 minus sum by augment of I comma I. That is the pivot element. And then we, after every step, after finding out every value of x, that is x, y, and z, we initialize the sum to 0. Because next step when we go, again we have to re-evaluate the sum at every step. Any doubts or confusions in the code, you can tell me. Any confusions, any doubts? Is it clear?
Yes, sir, clear.
Okay. So, okay. Now I'll run this code and I'll show you how the results are coming. See, once I run that code, it is asking me to enter the coefficient matrix, which is the A matrix I have to enter. What was my A matrix? Just a second. 1, 2, 1, colon, 2, 3, 4, 3, 5, 7, RHS matrix 8. While entering the RHS matrix, don't enter just 8, 20, 34. Then it will give you wrong answer. You have to divide. It is a column matrix, right? 8, 20, 34. So now this is done. If you click X here, see the value of X is 1, 2, and 3, which we had obtained using the Gaussian elimination. Okay, just for your clarity, I'll display the augmented matrix here also. If you see the augment, see your augment here 1218 0 minus 124 0026. So this is a upper triangular matrix because the elements below the principal diagonal are always 0. So now if I want to do it for a random thing, this we knew, right? So I am using a 5 for the sake of understanding. 4 cos 4 matrix I will use first. Randomly I'm entering. I don't know where the solution will come for that. RHS matrix 20. Oh, sorry. See, I didn't give the this colon, the semicolon. That's why the error came. There is an error here. What is the error? Second. Oh, I went at 3. No. I have to enter a 4 cross 4 matrix, right? 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16. Okay. See, x is coming as nan. So that means there is no solution for this type of equation. I have just randomly given, right? So that's why there is no solution for this kind of equation. So like this, you can take any 4 cross 4 system and you can find out what is the this thing. See here, the last element it is going as nan basically means not a number. That's why we are not getting any solution for this. So is this concept clear, or should I explain again the MATLAB code behind this? You can tell me if it is not clear. I can explain again. Or any specific doubts are there, you can ask me. Any doubts?
Sir, again, sir.
Sir,
Which part you didn't understand? Can you tell me? Then it will be better. Yes. Which part you didn't understand? Which part you want me to repeat?
Sir,
Can you repeat the upper
column,
triangular
sir,
method?
21.
So here in line 21 and 23 basically. So whatever just this is not possible. This I cannot explain you. You have to go through it because whatever you are doing in the pen and paper, just imagine that how we can translate it into code. Basically what we were doing, basically first we are taking the second row, then R2 minus 2 times R1. How we were getting that 2? That is basically A21 by A11, right? So this 2 we are trying to find it out here in this line 19 mult we are trying to find, where we are finding augment of 2 1 minus augment of 1 comma divided by augment of 1 comma 1. Like that we are trying to find out the mult. And then in this line 23, basically we are replacing we are updating the second row or the third row, the corresponding row by whatever elements are there previously, which is stored in augment of ii comma colon minus mult, which is the multiplier value, into augment of kk comma colon. So kk first is 1. For considering 1 as the pivot element, 1 as the pivot row, we are corresponding all the rows, second, third, fourth, we are all finding out the considering the first row as the pivot row, we are updating the second row, third row, fourth row. Once that is done, again we are changing the pivot row, that is so then we are changing the pivot row to second row. Again, for second row, from third column, we are basically updating the elements because all columns before the uh, pivot row, those are already updated. So here this II is always from KK plus 1 to N. So if KK is 1, that is the pivot row is the first row, then we are starting our update from the second column. Is this clear?
Sir, yes, sir.
Any other confusion? I know it is a bit difficult to understand, but you have to, I'll send you this code. You go through it again, line by line, you take n as low as possible, like 3 you take, then you try to dry run. So do you know how to dry run or how to see each and every step what is happening in the MATLAB code? Are you aware of that? How to check that?
no, sir.
Okay, so basically what you have to do is you have to put a breakpoint. Like if you click on the line number, here it will show you as a red colored dot. So now if you run this code, if you give the input, say, so it the execution will will come at line 15 and stop. Now you can use this step command is there, one by one it will execute. Each line it will execute and show you what is happening. So suppose now see, if you click on kk value is 1 now, and ii value is 2 now because kk is 1, so kk plus 1 is 2. So augment of ii comma kk, it is basically 2 comma 1 divided by 1 comma 1. So mult is now 2. Okay. So this augment of ii comma 1 colon means r2 equals to r2 minus mult is 2 into kk is 1. So r2 minus 2r1. Then it will calculate that. Now you can just in the command window you can type what is augment. If you see, only the second row is updated. See here augment, if you see only the previously, one second, I'll show you step by step. I'll show you how to do this. Okay, fine. Now you see what is augment. Now our operations have not started, right? So augment is this one. Now I do one step, one step, one step, one step. That is R2 is now updated. You check this one, augment. See, in these two matrices, if you compare, the first and the third rows are same. Only the second row is updated. So this element is already 0 now. Now our next target is this 3, we have to make it 0. So you do one more step, do one more step, do one more. This green arrow, it will show you the line at which the controller is presently in. So now if you, one more step is done, right? So now if you check augment, see the last row is also updated, 0 minus 1 4 10. So only one more step is remaining. Do one more step from here, one more step is done. See, now the 3 2 element is also 0 now. Like this if you do, now see this, it has come out of this loop. This elimination process is done. That is, it is converted to upper triangular matrix. Now it will go to the this back substitution. This one also you can check how it is being evaluated by this step command. You have to use the breakpoint at a particular line. So breakpoint means, see here it is saying if I put a red here, it will pause the execution at this line, and then it will go into the deep, go into the. It will show you step by step how it is happening. Is it clear? Is it clear? Can someone respond?
Yes, sir.
Javed, it is clear?
Yes, sir.
Yes, sir. Sir, I have a confusion that
Yes.
we can don't think we cannot get sir complex value for with this method, right, sir?
No, this is only for all the techniques which you are studying still till now. That is only for real equations. That is real numbers. We
Yes, sir.
don't include the complex terms here.
Yes, sir.
Anyone else? Any other confusions? Anyone?
No, sir.
Okay. Just I'll share this code. You go through this code, and if you have any other doubts, you can get back to me. So now we will move to the next topic, which is LU decomposition. Okay, just a second. So any one of you, are you aware of what is LU decomposition? How do we solve the matrix using the LU decomposition method? Anyone, any idea on LU decomposition method?
No, sir.
You have not used LU decomposition method anywhere in your electrical engineering power systems, anywhere you have not used? Okay, fine. I will describe you what is LU decomposition method. So L basically means the lower triangular matrix, right? So L is your lower triangular matrix. And U, as I told you, that is your upper triangular matrix. So according to the matrix theory, any matrix, any square matrix obviously, that can be represented as a product of one lower triangular matrix and one upper triangular matrix. any square matrix can be represented as a product of one lower triangular and upper triangular matrix. That is, any square matrix can be represented as a product of a lower triangular matrix and an upper triangular matrix. So the system of equations which we are trying to solve here is Ax equals to B, right? Now I am telling that your A is always a square matrix. So A can be represented as a product of L and U. We don't know what is L, what is U, but we can represent A as a combination of product of L and U. So here what we do, we replace A as L into U. So that is basically LU x equals to B. So now what we do is this matrix U into X that we basically represent as another matrix which is Y. So that will give me L into Y equals to B. You know what is L, what is U, and now Y we are introducing another matrix which is the product of U and X. So Ly equals to B, and now we will get Y will be equal to L inverse B. So from this we can find out what is Y, right? Sorry, we'll not use the inverse technique here. We will use this Gaussian elimination technique to find out Y. So now once we get Y, we will use this Ux equals to Y, right? This was the original equation. We know Y we have found out, we know U, we will find out X. Again, use Gaussian elimination technique to find out X. So our X is our ultimate goal, right? So once we have found out X, our solution is done. Is the algorithm clear? What we have,
Yes, sir.
I have told?
Yes, sir.
Okay. Can you tell me, any one of you, how we can, I have showed you how we can convert to upper triangular matrix. What is a lower triangular matrix? Can someone of you tell? What is a lower triangular matrix? Anyone?
So the zeros will be in the upper part.
The zeros will be in the upper of what?
Upper of the matrix.
Sir,
Upper of the matrix means
diagonal, sir.
Upper
yeah,
of the diagonal.
yeah,
Yes, upper of the
yeah.
diagonal.
All the elements above the principal diagonal will be non-zero, and all elements beneath the diagonal will be uh, zero. Sorry, the reverse one I told. All elements in a lower triangular matrix, all elements above the upper diagonal are zero, and all elements below the lower diagonal are non-zero, right? So now we will take the problem and we will try to solve using this LU decomposition method. So our A matrix is this one, right? 1, 2, 1. Then we have 2, 3, 4. We have 3, 5, 7. Then we have the RHS matrix, which is 8, 20, 30. Now, now we have to use our LU decomposition method. How we'll be using? So first, this A matrix we have to convert to L. Then we have to convert to U, right? A second. First, we'll be converting to upper triangular matrix. That we have already done. So I'll do that first we'll convert it into lower triangular matrix. So for lower triangular matrix, what we have to do, first we have to identify the diagonal. So this is my principal diagonal. So can you tell me which all elements should be 0 here? Any one of you? In this A matrix, I have identified the principal diagonal. Now which element should be 0 and which should be non-zero?
So in row 1, 2 and 1 will be 0, and row
Yes.
2 the 4 will be 0.
Yes, correct. So these three circled elements should be 0, right? So how can we do that? Any idea? We can use the row operations, right? Just like we did for the
We
upper
can,
triangular. Yes, Javed?
sir, we can multiply row 1 by 4, then subtract from row 2, put it on row 2, then, sir, in
Yes.
this way, can
Yes, we can do it using the similar procedure, but here I will describe you a different technique, which is a more mathematical technique, I will say, to find the L and U matrix. Okay, just try to understand it. So not using this row elimination and all. Uh, this row elimination becomes computationally very expensive when we do that. But we will try to see here a different technique. So what I told you, this A is the multiplication of L and U, right? So L matrix we can represent as A11, A12, 0. This is, sorry, both are 0, and this is also 0. A31, A32, A33. And what is my U matrix? Okay, 1 second. This I will represent by L is L11, L12, 0, L21, L22, 0. This will be 0. L31, L32, L33. U will be basically U11, U12, U13, 0, U22, U23, 0, 0, U33. So now, basically, we will be multiplying these two L and U matrix. Okay. So what will be L into U? L11, 0, 0, L21, L22, 0, L31, 32, L33. U22, U23, 0, 0, U33. So this multiplication is equal to my matrix, right? 1, 2, 1, 2, 3, 4, 3, 5, 7. So if we equate these two, if we multiply this L and U, how much we will get? First will be L11 into U11. Then we will get L21 into L21 into first row into first column, right? L21 into U11 equals to, sorry, 1 second. First row, okay. L11 into U12, L11, U12 equals to 2. From the third element, we will get L11 into U13 1 equals to 1. Then we will get L21 into L21 into U11, all are 0, that is equals to 2. Then we have L21 into U12 plus L22 into U22 equals to 3. Then we, yes, Javed, you want to say something?
No, sir.
Your mic is not muted. That is equal to 4. Last one we have L31 into U11 equals to 3. Then we have L31 into. Can you please mute your mic, Jamil? L31 into U L31 into U12 plus L32 into U22. L32 into U22. So that is equal to, again, 1 second. 1, 2, 1, 2, 3. Okay. L31 U1 equal to L31 U12 plus L32 into U22 equals to 5, and the last one is all elements will be there, plus L32 U23 L33 U33 equals to 7. So from these 6 equations there are 6 unknowns, right? 9 equations, and how many unknowns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We can find out these unknowns. See, this is equation number 1. Sorry. Equation number 2. This is equation 3, 4, 5, 6, 7, 8, and 9. Right. So now first we'll see first equation. If you see L11 into U11 equals to 1. So can you find out from this? You have to do some manipulations and then you can find out the values of L11, U11, L12, U12, all these values you can find out. But you have to do some manipulations for that. I'll just see if I can do it now. L11 into U13. Just a second. I think you can solve by this equations, but it will be, I think, more computationally expensive. That's why what we do is we think of the other method which we were doing previously, like the uh, your row elimination method, right? So what was my A matrix? Was 1, 2, 1, 2, 3, 4. So from this, what we learned is we can easily convert it into upper diagonal matrix first, upper triangular. These 3 elements we can remove, what that we had learned in the Gaussian elimination. So it was basically U was After the Gaussian elimination, what was the matrix? Can someone tell what was the matrix? So it is basically 1 2 1 0 minus 1 2 0 0 2 0. So it was basically 1 2 1 0 minus 1 2 0 0 2. So you have your U matrix now. Now how we can find out the L matrix? L into U was basically your A, right? So now L we know L11 L 0 0 L21 L22 0 0 L31 L32 L33 multiplied by U. What is U? 1 2 1 0 minus 1 2 0 0 2. That is equal to your this matrix 1 2 1 2 3 4 3 5 7. So now if we multiply these two, so first element we will, I'll write it here once again, L11 0 0 L21 L22 0 L31 L32 L33. So this is 1 2 1 0 minus 1 2 0 0 2, right? This is equal to 1 2 1 2 3 4 5 7. So now first element will be L11, right? L11 equals to, I'll do the multiplication, otherwise it will be difficult. What will be the first element? Can you tell after multiplying these two matrices? Anyone? What will be the first element?
L11.
So it is L11. The next element?
0 minus L22 0.
Yes, the second, this element I am talking about, the 1 2 element.
It will be 0.
It will be 0. How? How is it 0? First row into second column, right?
Yeah.
So it is L11 into 2, remaining all are 0. So it is 2L11.
Oh, yeah, yeah.
The next element?
L11.
So here it will be L21, right? Then this will be the second 2 2 element. Can you tell what it will be?
Two L21.
Anything else? It's 2L21 minus L22, right? Then we will get L21 plus 2L22. This one will be L31. This one will be 2L31 minus L32. This one will be L31 plus 2L32 plus 2L33. 1 2 1 2 3 4 3 5 7. Now from this, if we compare, we can write first equation L11 equals to 1. All this, the first row is the same thing. Then we can write L21 equals to 2 from the second row. From the second row, second element, we can write 2L21 minus L22 equals to 3. 4 minus L22 is 3. L22 is 1. 2 1 1 1 2 1 2 2 we have found out. The next one, we have found out this. So we move to the third row. It is L31 equals to 3. 2L31 minus L32 equals to 5. So it is minus L32 equal to 5 minus 6, which is minus 1. So L32 is 1. L31 plus 2L32 plus, is it plus? Oh, it is plus 2L33 equals to 7. From this we can find out L33. So 3 1 is 3 plus 2 plus 2 L33. So L33 is how much? 1. So we have found out all elements of the lower triangular matrix. So now we can write the lower triangular matrix as 1. Oh, L12 we have not found out. Oh, L12 is 0 anyways. 1 0 0. 1 0 0. L21 is how much? 2. 2 2 is 1. 2 1 0. 3 1 3 1 3 1 1. This is your L and this is your U. U is how much? 1 2 1. 0 minus 1 2. And we have 0 0. So now we have both L and U matrix. So now we are in a position to solve the equations. So this is half of the part is done. L and U matrix you have found out. Any confusions in the calculation of L and U matrix? So what is the basic algorithm? We will find out U matrix by your Gaussian elimination technique, which I have described earlier. Once you get U, you know L into U is equal to the coefficient matrix, which is A. So from that, by comparison, we can easily find out your L matrix. Is this clear? Any confusions?
No, sir.
Clear, right?
Yes, sir.
Okay. So now you have your L and U matrix. So what was my algorithm for LU decomposition? AX equals to B. Then you had LUX equals to B. We had UX equals to Y, right? We had assumed this UX. Uh, this UX matrix as Y. So from this we told we will find out our we'll find out the Y matrix first, right? This we have, and if we substitute this equation here, so it was basically Ly equals to B. We know L, we know Y, B we know. We can find out Y. Similarly, once we get Y, we can substitute it here, and then we know U, we know Y. We can find out X. So this is by calculation. It will take a lot of time if I do. Okay, I will do the first this Y matrix. I'll find out. Then I'll show you the MATLAB code for that. Just a second. Okay, so once we find out, we'll find out first Y, right? So we have Ly equals to B. So what is my L matrix? 1 0 0 2 1 0 3 1 1 1 0 0. Then we have 2 1 0 2 1 0 3 1 1. We need to find out Y, which is Y1, Y2, Y3 equals to B. B is your the RHS matrix. 8 20. So you can find out Y from here, which is basically L inverse into B. Just a second. So how we do that? So this is a lower triangular matrix. So what we have to do here is we have to do forward substitution. That is, we have to come down. That is, from top we have to start and then we have to go down. So first row, if I multiply with this column vector, how much we will get? we'll get y1 equals to 8. Then from the second row, 2y1 plus y2 equals to 20. From this, if we substitute, y2 will be equals to 4. From the last one, 3y1 plus y2 plus y3 equals to 34. From this, if I want to find out y3, it will be 3 is a 24 minus 24 plus 4, 28, 6. Y3 will be equal to 6. So now Y matrix you know, which is 8, 4, and 6. So Y matrix, if you know, you substitute it here. Ux equals to Y, right? Ux equals to Y. So what is U? U is the upper triangular matrix, which is 1, 2, 1, 0, minus 1, 2. Next page we'll do. Ux equals to Y. 1, 2, 1, 0, minus 1, 2, 0, 0, 2. X we want to find out x1, x2, x3 equals to Y means Y matrix is 8, 4, 6. So now here we have to do backward substitution, right? Back substitution. That is, we have to go from bottom to the top. Whenever there is L matrix, remember we have to do the forward substitution. That is, we have to come from top to bottom. Wherever there is this upper triangular matrix U, you have to do the back substitution. So if you substitute the last row, if you do 2x3 equals to 6, x3 will be equal to 3, minus from the second row, if you do it is equal to 4, x2 will be equal to 4 minus 6 minus 2, 2. X2 is 2, and this one x1 plus 2x2, 3 equals to 8. X1 will be 8 minus x2 minus 8. 2, 4, 8 minus 4, 4 minus 0. So now you have your X matrix, unknown X matrix. 1, 2, 3. Is this process clear?
Yes, sir.
Clear, right? LU decomposition, how I have done? Can someone of you just tell me once what is the algorithm basically to do this process? Yes, Javed, can you tell? Whatever you understood from this?
So I think this is the another method of solving equation,
Yes.
in which we can use alternatively with Gaussian eliminations.
Yes. Can you tell me
Gaussian
how,
elimination
what is
method.
the algorithm? Just can you tell me once? Whatever you understood.
I just forgot it, but we can do it by upper triangular matrix making upper
Hmm.
triangular matrix,
Hmm.
then backward substitution
Upper
then doing
triangular
the backward
matrix and back
substitution.
substitution was in the Gaussian elimination, right? So what is the
But,
difference between this Gaussian elimination and this LU decomposition method?
uh, 1 minute, sir. Sir, we have used a lower triangular matrix in this method.
Hmm.
Then to forward
Forward substitution, right?
forward substitution method for
Hmm.
extracting the value of x1, x2, and x3.
Correct. Okay. So you have understood. So now I will just show you the MATLAB code for this and explain the how to do it in MATLAB. Just a second. I'll share my screen. Is the screen visible?
Not yet, sir.
1 second. Now,
Yes, sir.
see what I have done here. This is the code for LU decomposition method. So here it is the same thing, right? We have A we have taken as the input coefficient matrix, B as the RHS matrix, N as the number of unknowns. Now here what we did, the difference with the previous method here is that in the previous method what we had done, we had formed the augmented matrix, right? So in LU decomposition method there is no concept of any augmented matrix. So what we do is we have to convert this A to upper triangular matrix, right? So upper triangular matrix, this U we will be storing. So basically we assume this coefficient matrix into U variable, because we will be performing all the operations on this U variable only, not on A, because A matrix we want to retain as it is. That's why we made a copy of this A matrix into the U matrix. So once this is done, then we do the same process just like we did in the previous thing. I have taken a loop from outer loop from 1 to n minus 1 and inner loop from kk plus 1 to n, found the mult here, multiplier. Then we have done the row operation. From this we have obtained what is called the upper triangular matrix, or U. So once you get U, we can find L from LU was equal to A, right? So L will be A into U inverse. In that process I found out the lower triangular matrix L. So once you have L and U, what was the algorithm? We were first using the forward substitution, then we were using the backward substitution, right? So forward substitution means your loop should always run in the forward direction. That is 1 to n. The outer loop should run from 1 to n. Whereas in back substitution, if you see, your outer loop will run from n to 1. And the inner loop will run from I minus 1 to 1. In that way we are finding the sum, that is the here we did just like we were solving for the first row, we were solving first, right? L11 into x1, L21 into x2, 12 into x2, L13 into x3 equals to b1. From that we found out what is x1, because L21 and 22 were 0, 12 and 13 were 0, so we found out L11. Similarly we are finding out this sum here. And once we have the sum, we can substitute it in this equation. This is the equation for forward substitution. And then similarly, just like the previous one, we also, so here the forward substitution should be done between L and B, not between A and B, because your equation was LU equals to Ly equals to B, right? So y you need to find out, and L and B where your unknown, y is your unknown and L and B are your known matrices here. So in this way we have found out in the y array we have the y values. Similarly, now you substitution here from line 47 till 59, what I have done is I have performed the back substitution between U and Y, not between B. Just remember this. Here your coefficient matrix in line 51, you can see we are performing this on U, and your RHS matrix is your Y. So once you do this, we will get X. So I will show you how to run, how is it coming. So coefficient matrix 4357 and this is 8. So you want the y values first. So you can see y values are 8, 4 and 6. You want to see your lower triangular matrix, it is this one which we found out in our equation also. U matrix is this one, 1 2 1 0 minus 1 2 0 0 2, and finally your solution, if you want to find out, it is 1 2 3. So this again, in order to understand this code, what is being happening in the forward substitution and the back substitution, you have to go through this code line by line. All of you have MATLAB software in your PCs or laptops?
Sir.
So then you have to basically, I'll send you these codes. You copy it in your system. Then put breakpoints at every point and then try to understand what is happening. If you don't get any line, you come back to me in the last class, or you can send me a mail or message in the WhatsApp group. If you are not getting any of the lines, what is happening? So now is it clear? Just I'll give you 2 minutes. Just tell me if you have any doubts. Any doubts? Any confusion? Any doubts? Any confusions? Anyone?
No, sir.
Clear, right?
Yes, sir.
Okay. Just take a 5 minutes break. I'll come back and we'll continue for another 15-20 minutes. Then we'll close the class for today. Just 5 minutes. I'll come back. Okay. So I'll start the session. Another half an hour I'll take, and two more methods I'll discuss, and then I'll wind up today's class. So you all are there? Am I audible?
Yes, sir.
sir.
Yes, sir.
I'll share my screen. Yeah. So now we will see. This was all about the different techniques to solve the linear system of equations, which was not iterative. So now we will see some techniques which are iterative techniques to solve the system of equations like Ax equals to b. Okay. The heading iterative techniques iterative techniques to solve Ax equals to b. Okay. So in this iterative techniques, we'll be learning two techniques basically here. First one is the Jacobi method, and the second one is the Gauss-Seidel method. So what we'll be basically doing, we'll first see what is the algorithm of the technique. We'll solve it in our pen and paper normally, some one or two iterations. Then we will move to the MATLAB code for better visualization. So what is the Jacobi method? First, we'll be talking about. So have you used this method anywhere in power systems or power electronics, anywhere, this Jacobi method and the Gauss-Seidel method?
No, sir.
No, sir.
Gauss-Seidel method you have not used in load flow analysis, you have studied in power
Yes, sir.
systems?
Yes, sir. Gauss flow is we have used, but Jacobi method is unfamiliar to us.
So can you tell me what is all about the Gauss-Seidel method? Any idea you can recall? Any idea? Can you recall what was the algorithm for Gauss-Seidel method? Anything?
No, sir. Right now, it's not in my mind.
Okay, fine, fine, no issues. I'll
Sir,
explain. Yes.
sir, here in Gauss-Seidel method we can use pi method or any other methods used for findings.
Okay. What is the algorithm? Can you tell me? Means fine, no issues. I'll explain you. Then you can tell me whatever you have understood from that. So basically, here first we need the coefficient matrix and the this source matrix or the RHS matrix, right? B is my RHS matrix, and A is my coefficient matrix. So in the previous techniques, we were needing only these two. But here, apart from this A and B matrix, we need to have another matrix, which is the initial value matrix. In the first day, I told you for any iterative technique, any iterative technique which we do, we need an initial value of the solution. Like you are asked to find out x, right here, the x vector. So, but you need an initial solution for x matrix. An initial guess will be given to you in the question. Based on the initial solution, you will try to improve that solution and approach towards the exact solution. Your initial solution, the values which are given in the initial solution will determine the number of iterations you need to complete your process. to approach. Suppose your actual value is, say, the values of three values of x are 5, 6 and 7, and your initial values are given as, say, 100, 200, 300. So those are totally different. So one is, I'm telling the initial value is, say, 100, 200, 300, and your final answer is 5, 6, 7. But you need to approach from 100, 200, 300 to 5, 6, 7. So you can understand just from intuition that it will take more number of steps or more iterations we have to do in order to approach to the uh, solution, exact solution. However, if you have a initial value which is close to the actual solution, then you can approach the actual solution in a much smaller number of steps. And also, in any real life problems or real world problems, this initial value will be provided to you, and you don't have a choice to select this initial value. This is a given in the question. So you don't have a control over the initial value, but your initial value will determine the number of iterations which you need to complete your algorithm or the calculation. Okay, so now we will see our initial value here is given as, so initial value we are representing as x subscript a superscript 0. That is, for the 0th iteration the value is given as 1, 2. Okay. Now in Jacobi method, what we will do is, first we have to write the, from the matrix form we have to convert it into equation form. So in the Gauss elimination and the LU decomposition method, what we did, our first job was to convert from equation to matrix. But here we don't need the matrix form, we need the equation form of the system. So the first equation, can you tell me what will be the first equation, Javed?
Sorry, sir, I missed the question. Can you again?
Yeah, from the A and B matrix, can you tell me what are the equations?
Sir, I guess it will be 2x1 plus x2 is equal to 1.
Yes. Second one?
X1 plus 2x2 plus x3 is equal to 2.
Yes. And last one is x2 plus
x2
x3
plus
equals to?
3 is equal to 4.
Yeah. So we have basically three equations, right? So what we do in Jacobi method is, I'll write down the equations again. 2x1 plus x2 equals to 1. x1 plus 2x2 plus x3 equals to 2. x3 equals to 4. So from equation 1, we will try to find out what is x2. Sorry, from equation 1, first we will try to find out x1. x1 of 1, that is x1 at the first iteration. This is our step 1 we are doing. Okay, x1 of 1 equals to 1 minus x2 of 0 by 2. So your x of 0 is given as 1, 2. So this is your x1 of 0, this is your x2 0, and this is your x3 of 0. So from this we will get 1 minus 2 by 2 equals to minus 0.5. Similarly, from the second equation, we will try to find out what is x2. It is 2 minus x1 minus x3 by 2. These are all zeroth. That is, we are in the first step and we will be using the values of x1, x2 and x3 of the previous step. We will not update the values here. So it is 2 minus x1 of 0 is 1, x3 of 0 is 1 divided by 2 equals to 0. From the third equation, we will try to find out what is x3. It is 4 minus x2 of 0. So first step we have completed. Is this process clear? How did I get it?
Yes, sir.
Yes, sir.
Okay. So can you tell me what will be the step 2? Equations will be same. From first we will get x1 of 2, now we will write is 1 minus x2 of 1 by 2. 1 minus x2 of 1 is how much? In the last step
That
we got,
x2 of
right?
1 was 0, sir.
1 minus 0 by 2, it is 0.5. Second step, x2 of 2 equals to 2 minus x1 of 1 by 2. So it is 2 minus 0.5 minus 2 by 2, 0.25, right? x3 of 2 is 4 minus x2 of 2. Basically, sorry, x2 of 1. x2 of 1 is 0. So it is 4. So now, how many iterations do we need to continue? So you see, at every step, what you have to do, you have to see the value of x1 is, first step it is minus 0.5. Second step it changed to 0.5. So there is a huge deviation. Value of x2 is 0 in the first step. In the second step it is 0.25. Third step, first step x3 value is 2 and third step x3 value is 4. So the error is, the difference, the deviation is huge. So at every step you have to check the deviation, that is the difference between the x1 values in the present iteration and the previous iteration. So once it is less than the tolerance value, which is generally around 10 to the power minus 3 or 10 to the power minus 4, then you can stop your iterations. So here I will not do any other further steps. We have to continue, at least 50 to 60 steps will be there like this. So you cannot do it by hand. We have to do it using our programming, either MATLAB or Python code. So we'll see the MATLAB code for this. Is this process clear?
Yes, sir.
Okay. And so here the main thing which you need to understand is, when we are finding this x1 value at the second iteration, we are using the value of x2 of the previous iteration, not of the current iteration. However, the difference is, in Gauss-Seidel method we will see, at every step we will be using the updated value of x. So we'll see how to do, we'll see the algorithm for Gauss-Seidel method also. So Gauss-Seidel method, the first equation is 2x1 plus x2 equals to 1. x1 plus 2x2 plus x3 equals to 2. x2 plus x3 equals to 4. These are the three equations, right? And your x of 0 was given as 1, 2, 1. So from the first equation, in the first step, what we will do is, from the first equation, x2 of 1 is equal to 1 minus, sorry, first equation will get x1 of 1 minus x2 by 2. Now, see, in the first step, at the first step, we, whatever value of x2 we have, it is the 0th iteration step we have, that is 2 here. So we'll be using that. It is minus 0.5. Now, second, when we go x2 of 2, it is 2 minus x1 minus x3 by 2, right? Now, we will no more, in the Jacobi method, what we were doing is, for x2 of 1, we were using x1 of 0 and x3 of 0. But here what we will do is, for x1, we will use the previous value, that is x1 of 1, the current, the most updated value. This is this 1 which is given, that is at the 0th iteration. Whereas at the first iteration, it is minus 0.5. So x1 we will use here minus 0.5. However, for x3, we don't have the updated value, right? So we will use the previous value only. So it is 2 minus 0.5 minus 1 by 2. Is it clear?
Yes, sir.
Can you tell me what will be x3 then? 4 minus x2 by 2. So x2, which value should I use?
Sir, first iteration value,
1.75.
that means x2 of 1, sir.
Yeah. So it should be x2 of 1, not x2 of 0, because we have already found out x2 of 1. it will be around, oh, so by 2 was not there. It is 2.25. So you may ask me the question why we are doing this, why we are updating the values. Okay, one more step I'll do, then I'll explain. Can you tell me what will be x1 of 2? Which value of x2 should I use?
Sir, x2 of 1.
Yeah, so it is 1.75, right?
Yes, sir.
1.75 by 2. 1 second, 2 minus 1, 1, 1 point. So it is wrong. It is 0.75. So this is 0.75. So 1 minus 0.75 by 2, it is 0.125. Okay, now for x2 of 2, can you tell me which value of x1 and x3 should I use? x1 of what should I
X2 of
use?
1 or x3 of 1, x2 of 1.
No, we are finding out x2 of 2. So x1 of which one should I use?
1. Sir, x1 of 2, sir. Then x3 of 1.
2 minus 0.125 minus 3.25 by 2. We'll get here minus 0.6875. Similarly, for x3 of 2, we will use x2 of 2, right? Again, every step you have to find the deviation. That is x3 of 2 is 4.6875, x3 of 1 is 3.25. So difference is there. Again, every you have to find out. So you can ask me the question that why we are using this updated value. So this is to reduce the number of iterations. So if I once I show you the MATLAB code, okay, so your homework will be to, I'll show you the code for the Jacobi method. You have to write the code for the Gauss-Seidel method. Okay, you have to write, the homework will be, I'll show you, I'll explain you just now the code for Jacobi method. You have to write a MATLAB code for Gauss-Seidel method. So your inputs I am mentioning, input will be coefficient matrix, RHS matrix, and your initial solution. These three will be your input, and your output should be value of x at each iteration and final value of x and the number of iterations required. These three things you should print as output. So basically you can see if
What
you
could
write
be the
the
tolerance?
tolerance should be, okay, tolerance I will tell you, tolerance should be 10 to the power minus 3. This is the relative tolerance, okay? This should be 10 to the power minus 3. Clear? The question is clear?
Yes, sir.
Okay. So here in the Gauss-Seidel method, if you compare the Jacobi method and the Gauss-Seidel method in the MATLAB, once you write the code for both, then you can see that in Gauss-Seidel method, the number of iterations required to achieve a particular tolerance will be much lower compared to your this Jacobi method. Because in Gauss-Seidel method, we are assuming in Gauss-Seidel method we are using the most updated value at each step of iteration. Okay. So now I'll show you the code. I'll explain the code for the Jacobi method. Is the screen visible?
Not yet, sir.
Now it is visible?
Yes, sir.
Yes, sir.
Okay. So in Jacobi method, first you have to take A and B as input, right? Coefficient matrix and RHS matrix. N is the number of unknowns. X is here the initial value. Initial solution. This will be given. The error first, I am taking as very high value so that we can first enter the loop. Any value you can assume here. I'm taking a counter k, that is the to track the number of iterations. This is to track number of, and this sum one, this is to basically to find out the total error. Okay. So now here, one thing you need to understand this iterative methods. Do you know the difference between for loop and while loop? What is the basic difference when we use for loop and when we use while loop? In any code, in any programming, do you know what is the difference between for loop and while loop? When to use which one? Any idea?
No, sir. Sir,
Okay.
I think it's the structural difference between.
Yeah, structural difference obviously, but how do you know when should I use for loop, when should I use while loop? So when you know, suppose you are asked in the basic programming, first you learn how to print. Say you have to print all the numbers from 1 to 100. So you know that your starting point is 1, ending point is 100. And and you know how many times you have to iterate, how many times you have to repeat the thing. So then you use for loop. But while loop is used when you don't know how many number of iterations are there, what is my starting point, what is my ending point. When these things are not known to us, we use the while loop. So for loop is basically an entry controlled loop, and your while loop is basically an exit controlled loop. Okay. So when you don't know what is the number of iterations, only you know the stopping condition, then we use while loop. So just remember, in this numerical methods, always when we want our tolerance to be within a particular limit, we know only the stopping condition. We don't know how many times it should iterate. So basically we use while loop here. So while our error is greater than equal to 10 to the power minus 3, I am doing this entire operation. So this is for ii equals to 1 to n, jj equals to 1 to n, that is through the matrix thing. And here we are finding out, see, here you need to understand one thing, why I am using ii not equal to jj. One second. Just a second, I'll just bring my pen here. Okay. So the thing is here, when you can just understand this, when I am using okay, one second. I'll explain this how this is coming. To stop sharing this one. Just a second. So if you see here carefully, what we are doing is this value is A11, right? Here there is 1, which is A12. Then we have another term here, A13, which is not there. This is A21, 22. Here is A23. Similarly, here A31, 333, this is 32, and 31 is there. So basically, what you have to do is you have to take a generalized form first. Okay, like I'll explain you. So it is A11x1, A12x2, A13x3 equals to B1. Okay. Similarly, A21x1, A22x2, A23x3 equals to B2. A31x1 plus A32x2, A33x3 equals to B3. So from first equation, we are trying to find out x1, right? So what will be my expression for x1? Just generalized form. A12x2, x3 by a11. From the second equation, if I want to find out what is x2, b2 minus a21 x1 my plus a23 x3 divided by a2. x3 is a31 x1 a32 x2 divided by. So from these three equations, can you generalize this thing? See here, once we are finding out x of 1, here it is 1, x2, this is 2, this is x3, this is 3. And this one, within the bracket, this sum, it is the row element is the value of the ID corresponding the value of x which you are finding out 1, and this column number 2 3 like this, it is continuing. Only the particular value which you are evaluating, that is x1, that term is not there. Here a11 term is not there. Similarly here if you see a22 term is not there. Here if you see a33 term is not there. So this thing you have to understand, and the denominator you can see it is a11 for x1, a22 for x2, and a33 for x3. So whenever the generalization, you can generalize it. Is it clear? Yes. Any confusion? Okay,
Sir, I have been
Javed,
facing some network
can you
issue.
confirm?
Sir, I have been facing some network issue. Can you again explain it?
Okay, just a second. I'll explain from the code itself. You just see the recording here. I have just explained uh, how we can find out the generalized expression for this x value. You can just check the
Okay,
recording
sir.
once, okay? Because
Okay, sir. Okay, sir.
okay. So here you can see, as I have explained, if ii is not equal to jj, that is ii is the value of x for which we are finding. That is the for first iteration, it is x of 1. So for x of 1, we are summing x2 into a12, x3 into a13, and we are finding out what is the sum of that. Once we go out of the column loop, we find out the value of x, which is b of ii minus this sum divided by the diagonal element corresponding to that, which is a11. Once we are done with that, we initialize the sum 1 to again to 0. So this we repeat, and we find the value of x for all the suppose there are 3 cross 3 matrix, so 3 values of x we will get. So basically here I represents the x2, x3, and k here represents at which iteration it is happening. So then the first after one is after this x1, x2, x3 is calculated for once, what we do is we find out the error. Now here error you need to understand. Error basically we have to find the difference between the all the x values, right? There are three, suppose 3 cross 3 matrix, there are 3 x values. So here we are finding out for 1 to n, we are finding out the difference between these 3 x values. That is x of ii comma k is the value of x at kth iteration with respect to k minus 1 is the previous iteration, and we calculate this error. So error variable that calculates error E variable for x1, x2, and x3. Then what we do is we find the average error, which is one absolute of sum of this one divided by n, which is the number of unknowns. Right. So from error 1, we then we increment this iteration. Okay, is it clear? Tomorrow, next class, I will explain it once again. So your homework for this week is you have to write the code for Gauss-Seidel method. Everything will be same here. Just I'm giving a hint. This will change. This x value here, which I'm updating here. Here you have to check some condition, and then you have to put the updated value of x here. Okay. So I'll close the class for today. We'll meet again in the next session. Fine. Any confusions, any doubts? Yes, Javed, you are not able to see the MATLAB screen.
Yes, sir. I can't see anything on the screen. I only see your screen, but no MATLAB screen. This.
Okay. Okay, fine. Then okay, we'll share the code with you because time is running out today. I'll share with every one of you all the codes which I have run today, and you can get back to me if you have any doubts. Okay.
Okay, sir.
Okay, sir.
Others, could you see the MATLAB screen at the last what I explained? Mustafa,
Yes,
can
sir.
you tell whether you saw the MATLAB screen? You could see?
No, sir.
No, sir.
Yes, Maruf?
No, sir.
Oh, you could not see. Okay, then I'll share it once. You should have
No,
told me.
sir.
No? Now it is visible?
Not yet.
Is it visible, Javed? Okay, 1 second.
Not yet, sir.
1 second. Now,
Not yet, sir.
okay, some net issue, I think. Again, I'll try sharing. No. It is not visible, Javed?
No, sir.
No, sir.
Okay, then. Okay, then what I'll do is maybe some network issue from my side also. I'll print this LU decomposition and all these methods. Previous screens, could you see when I shared?
Yes, sir. But in the last we can't see anything, and your explanation was not coming properly for.
Oh, okay. Okay, I'll upload the recording of this, and next class again I'll see from this Jacobi method. Okay.
Okay, sir.
Okay, sir.
So no need to do the homework for this week then. We'll again explain in the next class. Then we can do you can do the homework. Okay.
Okay, sir.
Okay, sir.
Okay, sir.
Okay. I'll circulate a form for the feedback. Just fill that. Only the feedback. Homework is not needed for this week. Okay, fine. Thank you. We'll meet again next Friday, 6:30.
Thank you, sir.
Thank you,
Thank you, sir.
sir.